Guys, I hope you guys are doing fantastic. I want to get into it with you today with this particular question over here. This is from May-June 2025. This is a grade 12 paper, Financial Mathematics. So 7.1, we have John invests an amount of money in an account paying interest at a rate of 15% per annum compounded monthly. Calculate the annual effective interest rate of this investment. So I've already seen this particular question before in one of the previous papers. This is a question that requires us to convert a nominal interest into an effective interest. So from our previous video, if you want to know what effective interest is and nominal interest is, you can go to the previous video. And then now 7.1, the formula for us to convert nominal interest to effective interest we use is going to be 7.1. We're going to use 1 plus I effective equals to 1 plus I norm over m raised to the power of m. Right. We're looking for our effective. We have our nominal interest, which is 15% per annum, and the compounding period is monthly. So we're going to say 1 plus I effective equals to 1 plus our I nominal is 15%, and then the compounding period is monthly. We divide that by 12. And then raise it to the power of 12. Right. Now, because we're looking for our I effective, we need to take this positive 1 over to the other side of the equal sign. And when we do so, it changes its sign from being positive to negative. So we're going to have I effective equals to 1 plus 15% over 12 raised to the 12, and then minus 1. And then we hit this on the calculator. Let's open our bracket. It's going to be 1 plus 15%, looking for 100%. The compounding period is monthly, close the bracket. And then we're going to raise it to the power of 12, and then we're subtracting 1 from it. At that, we get 0.16. Looking at this over here, 0.160755, right? So then after this, because we have this number over here, we're going to take it to a percentage because our interest rate, our effective interest rate is a percentage. So we're going to multiply that by 100. So our I effective over here, right now, it's currently, just go back. Then we're going to multiply that by 100. So going back to this, 0.10, multiply that by 100. And then we get 16.08%. 16.08%. That is our I effective. And then the second question over here, we have 7.2, says that Tino invests 50,000 in an account earning interest at the rate of 6% per annum, compounded quarterly. Tino decides to withdraw 11,250 at the end of every 3 months. Tino will continue making these regular withdrawals until there is no money in the account. How many withdrawals of 11,250 will Tino be able to make? So this is what looks like a withdrawal question, right? There is withdrawals happening over here. So here's Tino. He takes 500,000, invests it in an account. This account earns interest at the rate of 6% per annum compounded quarterly. Tino decides to withdraw 11,250 rands at the end of every 3 months. Tino will continue making these regular withdrawals until there is no money in the account. How many withdrawals of 11,250 will Tino be able to make? So it's a withdrawal question, right? So we know with withdrawal questions, when you're dealing with withdrawals, you're going to use the present value formula. So in the case of someone winning the lottery and then investing the money and making withdrawals, in order to calculate everything regarding those withdrawals, you're going to use the present value formula. That's great. So what are they looking for now? They're looking for how many withdrawals of 11,250 will Tino be able to make. So basically, they're looking for N. We're looking for N. So we're going to say PV equals to X into 1 minus 1 plus I, all raised to the power of minus N. Close that. Then divide everything here by I. So now we're going to substitute. we have our PV, which is our 500,000, right? So this is where he's taking this money from. And then we have 11,250 withdrawals, 11,250 amount of withdrawals. And then we're going to have 1 minus 1, and then plus our interest rate is 6% per annum compounded quarterly. It's going to be 6% per annum compounded quarterly, and it's going to be 4. And then we're looking for N. We're looking for N, then dividing everything here by our interest rate, which is 6% quarterly. So now our aim is to solve for N. We're going to have to take everything to the other side and then solve, right? So I'm going to first multiply by 6% divided by 4, right? I'm going to multiply that on both sides. So it's going to be 500,000 rands multiplied by 6% over 4. And then over on the other side, I'm left with 11,250 into 1 minus 1 plus 6% over 4. And then minus N. Let me close my bracket right there. Then I'm going to divide by this number over here, 11,250, to get rid of it. So I have 500,000, which multiplies the 6% over the 4, which is now divided by, do it nicely, divided by the 11,250. Over on the other side, I have 1 minus 1 plus 6% over 4, all raised to the power of minus N. So remember, the 11,250 has been erased on this side because I divided by both sides. Now I'm going to take 1 to this side over here. Let me take this writings to this so that I have space. So I have my 500,000 multiplied by 6% for the 4, all divided by 11,250. Then the 1 that goes to this side becomes minus 1. And then I have minus 1 plus 6% of 4, all raised to the power of minus N. Right. So now over on this side, I'm going to hit this on the calculator, right? Because it's this entire thing over here. I'm going to go to my calculator. That's 500,000 multiplied by the 6% over 4 divided by 11,250 minus 1. I'm going to start off with my 500,000. Then it multiplies the 6% over 4. And then I divide everything by 11,250. Then I subtract 1 from that. And then I get minus 0.333. Right. I have minus 0.33. This is recarried. And then we have minus 1 plus 6% over 4, all raised to the minus N. So now over here, I'm looking for my exponent. I'm looking for N. And to make my exponent subject to the formula, I know that I need to use logs. But then before I use logs, I'm going to get rid of these negatives that are in front, these 2 negatives over here, right? So implying that I'm going to have 0.3, let me just write the recarried over here. It's fine. Then over here, I have 1 plus 6% over 4, all raised to the power of minus N. Now I'm taking it here. Now. Cool. Just to make sure that everything is nicely followed. This one. Cool. So now I'm going to start off by using logs. I'm going to drop this minus N as my subject of the formula and then introduce logs. Right. Now the base, which was 1 plus 6% over 4, it's still going to be the base. 1 plus 6% over 4. And then this, which was the subject of the formula, it's now going to be the exponent of the log. 0.33 recarried. Right. And then I'm going to go over on my calculator. That is 1 plus 6% over 4, all raised to the power of 0.33. The log of, open the bracket, 1 plus 6% over 4, close the bracket, all raised to the power of 0.33. Put that on the calculator, I get minus 73.855. Minus 73, which means that my minus N is minus 73.855. Let me just see it again. 73,855. So now multiplying both sides n by minus 1 rather, I get my n as 73,86, rounding it off to 2 decimal places. So now what they wanted to know was how many withdrawals of 11,250 will Tino be able to make. So we can see it's 73,86, but then it means that full 11,250 withdrawals will be 73 of them. But then the last one, which is the 0,861, will not be a full 11,250 withdrawals. So only 73 withdrawals of 11,250 will be made. Now let's head over to question 3 over here. On the 1st of March 2021, Abby made a once-off deposit of 12,000 rather, into an account earning interest at a rate of 9.5% per annum, compounded monthly. She deposited 500 into the same account on the 1st of April 2025 and continues to make these monthly deposits of 500 on the final day of each month thereafter. Calculate how much money was in the account immediately after the deposit of 500 is made on the 1st of March 2025, exactly 4 full years after he initially deposits. Now this is very interesting over here. Mind you guys, I'm doing this thing first time with you, so you're gonna see how I go through the questions as I nitpick every little element in the question. So on the 1st of March, Abby made a once-off deposit. So this deposit was once-off of 12,000 rands into an account earning interest at a rate of 9.5% per annum compounded monthly. So this is another important point as it. And then she deposited 500. Now something else is happening. Initially, Abby just made a deposit of 12,000 into an account earning interest at 9.5% compounded monthly. That's what Abby did initially on the 1st of March 2021. Also an important thing. And then now something else is happening. She deposited 500. Now there's another deposit of 500 into the same account on the 1st of April 2023. So by the looks of things, it's almost from the 1st of March 2021 to the 1st of April 2023. That's almost 2 years. Right, somewhere around there it will have to calculate the period. And then, okay, on the April, and continues to make these monthly deposits of 500 on the first day of each month thereafter. So now this is happening every month, right? So now this becomes an annuity. So at first, Abby just made a payment of 12,000 into an account, earning interest at compounded monthly. Now she's then making regular payments every month on the first of every month of 500. Now it's becoming an annuity. Initially, it wasn't an annuity, but then now it's becoming an annuity. Remember, the difference between an annuity and of investment is that for an annuity, we're making regular payments at fixed intervals of time, right? So now the says that we need to calculate how much money was in the account immediately after the deposit of 500 is made on the 1st of March 2025, exactly 4 full years after her initial deposit. So they want to know on the 1st of March 2025, how much money would this person have made after the deposit of 500 is made on the 1st of March 2025, exactly 4 full years after her initial deposit. Okay, cool. So now we need to separate this into 2, right? So now our once-off payment of 12,000 is going to run for 4 full years, right? It's going to gain interest for 4 full years via the compound interest. So let's find out how much that is. So it's going to be A equals to E into 1 plus I all to the power of n, right? So I'm going to substitute. It's 12,000 1 plus, it's running for at 9.5% monthly, and then it's running for 4 full years, because that's her first initial payment, 12,000. It ran for 4 full years, and it was not an annuity, it was just a once-off payment. So I hit that on the calculator. Just want to write these things well. That's going to be 12,000. There's a minus in front of the 12, I don't like that. 12,000 The interest rate is 9.5%. That's monthly. So we're gonna have 17,521,18. So that's, just make sure, 18, yes. So that's her investment of 12,000. What amount it became after those 4 full years. But then now here's the kicker. The second part of the 500,000, or rather of the 500, is an annuity. And when is her first payment? It's on the 1st of April 2023, right? So now if we go from the 1st of March 2021 to the 1st of March 2023, that's 2 full years. That's 2 full years. And then, but then, if we April on 2023, that's March, April, it means that it's 2 full years and a month. Let's think about that. 1st of March 2021, that's Abby's first payment. So, implying that this person's first payment was 2 years late, was exactly 2 years late, right? So, implying that from the 1st of April 2023 to the 1st of March 2025, that's another 2 years. So our annuity is going to run for 2 years. So we're gonna say, okay, cool. Because it's our future value annuity, because we're making payments into an investment, 1 plus I to the power of n minus 1, do it nicely, over I. Then we're making 500 payments, 9.5% interest, compounded monthly, for 2 years, minus 1. And then divide all of that by 9.5% over 12. And then we hit that on the calculator. That is 500 rands. Double the brackets, 1 plus of 9.5%. That's monthly. What is that? And this is running for 2 years. And then I just wanted to carry everything and then divide it by the interest, which is also a fraction. Put the percentage on it. Oh, that percentage is on the wrong one. We hit that on the calculator. We get 13,158,65. 13,158,65. 13,158,65. So implying that the total amount would be the addition of these two things. The amount that he placed, the 12,000 that he placed, and then it ran for 4 full years, and then the annuity of 500 rands that he was paying every month. So it's going to be the 17,521,8 plus the 13,158,65. And then we hit this on the calculator, 17,521,18. So I'm just going to add this with the 17,521,18. And then we get 30,679,83. 30,689. See what it is. 30,679,83. 679,83. So this is the total that Abby would get.